Alright guys, so this is the video for 7.3 part 1. We're going to do this in 2 different days, but we're going to learn how to simplify rational expressions when we multiply and when we divide. Okay, so just kind of as an easier one, we're going to look at A and B here in example 1. Now to simplify this, before we even think about multiplying or dividing, to simplify this, we're going to use factoring. Now we should all be pros at factoring right now, and if you're not, please go see your Algebra 2 teacher and get some help or watch some YouTube videos, because you have got to be a master of factoring in order to be successful from here on out in chapter 7. Alright, so we can look at this and we can see this numerator here can factor nicely. This will be x minus 6 and x plus 2. Okay, and then the denominator, the x squared minus 4, this is a difference of squares, so it's going to be x minus 2 and x plus 2. Okay, once again, that's just factoring the numerator and the denominator. Okay, after we factor, we are going to look for like terms that we can cancel out. So notice we have an x plus 2 and an x plus 2, and we can cancel those out. Okay, so what we're left with is x minus 6 over x minus 2, and this cannot simplify. Okay, so this is our final answer, but we have to restrict the domain. Okay, so remember, the denominator of our fraction at any point, at this point, at this point, and at this point, cannot be equal to 0. So we want to go and find the x values that would make the denominator 0. Well, guys, if this x here is 2, it'd be 0 times 4, which is 0. Or if this here is equal to negative 2, it would be it would be 0 times, if this is negative 2, negative 4, which would also be 0. So both x equals 2 and x minus 2 should be excluded. So x cannot equal to 2, and x cannot equal to negative 2, and then this here is our final answer. Okay, now one thing I do want to point out is our book, when you do your homework, our book, because the denominator here is x minus 2, it's assumed that the author or the reader or whoever knows that x is not equal to 2 is a solution. We are not going to do that. So when you put this in big ideas, you won't have to put the x is not equal to 2 because it stays in here. But on tests, quizzes, whatever, you need to make sure you put both, because that is the correct answer. Okay, now let's look at part B. Okay, so once again, we're going to factor this. So this is x minus 4 and x plus 3. And then the denominator, once again, we have difference of squares. So this is just x minus 3 and x plus 3. Okay, from here, we're going to look at our common factors. So x plus 3, x plus 3. So when we cancel those out, we'd get x minus 4 over x minus 3. And then once again, we have to write what x cannot equal. Well, right here, what makes this parenthesis 0 would be x equals 3. And what makes this parenthesis equal 0 when x cannot equal negative 3. So 3 and negative 3 will not be in our domain. Okay. And once again, because this is x minus 3, when you put in big ideas, they won't make you put in this answer, but it is correct to put in that answer. So on a test or a quiz, please make sure you include that, even though big ideas doesn't make you on your homework. All right, if you feel like you want some more practice with just simplifying regular ones, go ahead and pause this video, do these on your own, and then I'll come back with the answers. All right, so if you went ahead and did these, this should have been what you got. All right, now that we know how to simplify, we're going to look at multiplying them now, okay? So I'm going to show you 2 different ways that you can do this, and you can choose whatever way you prefer. Obviously, I have my way, but it's just a matter of preference, okay? So when we're multiplying, here's method 1 that you could do, okay? So you have 8x cubed times y over 2xy squared times 7x to the 4th, y to the 3rd over 4y. Okay, so the first thing you could do is you can simplify each of these rational expressions separately. Okay, so 8 over 2 is 4. x cubed over x is x squared. Y over y squared is just over y. Times 7 over 4 does not simplify. X to the fourth, and there's no x on bottom, so that's just x to the fourth. And then y to the third over y is just y squared. Okay, so you could do it this way, and then you can multiply straight across. So this would just be like 4x squared times 7x to the fourth y squared over 4y. Okay, and then if we combine these, this is 28x to the sixth y squared over 4y. Okay, and then from here, you would have to simplify again. So 28 over 4 is 7. Okay, there's still just the x to the sixth. Y squared over y is just y. Here's your final answer. Okay, don't forget you have to make exclusions to your domain. So anywhere in any of these, if a variable makes it 0, the denominator 0, you have to. So we can see x cannot equal to 0 and y cannot equal to 0. So x cannot equal to 0, y cannot equal to 0, and here's your final answer. All right, another way you could do this, so 8x cubed y times 7x to the fourth, y to the third, over 2xy squared and 4y. And this is the way I prefer, and it's just a matter of preference, so that doesn't mean you have to prefer it. I just go ahead and multiply straight across. So 8 times 7 is 56. X cubed times x to the fourth is x to the seventh. And then y times y cubed is y to the fourth. Over, well, 2 times 4 is 8. We just have the 1x. And then y squared times y is y to the third. Okay, so I just do that straight up, and then I simplify from here. Okay, so 56 over 8 is 7. X to the seventh over x is just x to the sixth. And y to the fourth over y to the third is just y. Okay, and then once again, we have to say that x cannot equal to 0 and y cannot equal to 0. And here's my answer. Okay, so notice you get the same thing both sides. And guys, there's sometimes that one is quicker than the other. Sometimes one is longer than the other. And it really is. It's just a matter of preference. Both will work. All right, so I want you to go ahead and try to do example or part B in example 2, and then we'll go over it. But try to do this on your own. Go ahead, pause this, try to do it on your own, and then we'll go over it. All right, I went ahead and worked it out both ways, but this is what you should have gotten. You should have ended up getting 9x to the sixth over y, and x and y both cannot equal to 0. All right, let's look at example 3 now, okay? So once again, this is all about factoring. So 3x minus 3x squared, this is just 3x 1 minus x over, and then this here factors nicely to x plus 5 and x minus 1, okay? And then if I take the second term, it's going to multiply by, the top factors nicely to x plus 5 and x minus 4 over just 3x. Okay, now when I put these together, okay, I get 3x times 1 minus x times x plus 5 times x minus 4 over x plus 5, x minus 1, and 3x. Okay, so from here I can start crossing stuff out. So my 3x and my 3x, my x plus 5 and my x plus 5, so I'm left with 1 minus x, x minus 4, over x minus 1. All right, now if I look at this, I notice that this is very similar to this, okay? All right, so I can actually do a little trick here to help one of them cancel out. So think I can multiply both of these by a -1 over a -1, okay? Now what that does is this just makes it a negative 1 minus x times x minus 4 over a negative x minus 1. Okay, now I'm going to leave this negative here in front, and I'm going to go ahead and distribute this through. Okay, so 1 minus x, x minus 4, and this becomes a negative x plus 1. Okay, now I want you guys to recognize that negative x plus 1 can also be written as 1 minus x. Okay, so negative 1 minus x, x minus 4. And the reason I did that, because these now cancel. Okay, so here I'm left with just a negative x minus 4. And if I clean that up a little bit, that's negative x plus 4, or it's 4 minus x. Okay, so that's what this whole thing reduces to. And then I want to go back and I want to take care of my domain restrictions. So if I take care of my domain restrictions, I have that x cannot equal to 0, x cannot equal to negative 5 or 1, and here's a 1, 0, 1, negative 5, this is a 1. All right, so we should be good. This is my final answer. All right, let's look at B for example 3. Okay, now this can kind of complicate you, but I think a lot of you, if you just put this over 1, it'll make life a lot easier. Okay, so once again, I'm just going to simplify. So this is x plus 2 over, this x cubed minus 7 is a difference of cubes. So we have x minus 3, x squared plus 3x plus 9 times, and then this here does not factor, so x squared plus 3x plus 9 over 1. Okay, if I put it all together, I have x plus 2 times x squared plus 3x plus 9 over x minus 3, x squared plus 3x plus 9, and then just times 1, which we don't have to worry about. So here and here, these go away. So I'm left with x plus 2 and x minus 3. Okay, now I have to take care of my domain. So I have that x cannot equal to 3. And guys, if I look at this, okay, if I want to see what my zeros of this are, they don't factor, so they can't be nice zeros, but I still could have like a square root of 5 or something. So remember the determinant, b squared minus 4ac. If this is less than 0, there would be no real solution. So if I do b squared, so 3 squared 9, minus 4 times a times c, this is 9 minus 36. That is definitely less than 0. So there is no real solutions here, so I don't have to worry about there being any domain restrictions because they're imaginary. So this right here would be my final answer. All right, using B that we just did as an example, I want you to go ahead and try to work through this one on your own and come to the right answer, and then we'll go over it. So go ahead and pause this, work through it, and then check yourself. All right, so this is what you should have gotten for your final answer. Okay, so once again, we have a difference of cubes, so make sure you factor that out correctly. And then this and this goes away. And then I did our x cannot equal to negative 2 because that would make this value 0. And I went to check to see what would make this value 0, and I found that it had 2 imaginary zeros. So we don't have to include the imaginary numbers. So this should have been your final answer. All right, so if you feel like you need extra practice, go ahead and work these ones out. Pause this video, work them out, and then I will post the solutions so you can check yourself, kind of see if you made a mistake, try to find where it was. All right, so if you did the monitoring progress, this is what you should have gotten for these 3.